We're looking at reciprocals today, going to do a bit of a deep dive. Okay, the very first thing we want to look at is the notation. We want to tighten that up. Previously, we saw you could say you have some number a, you want to take the reciprocal of that. What's that going to be? Well, that'll be 1 over a. Okay, so for example, we start with the number 25. What's the reciprocal of 25? Well, that's just 1 over 25. Fairly straightforward, but this arrow is a little bit ambiguous. Arrow doesn't always mean take the reciprocal of this, right? So we want a better notation. To get there, I want to first look at taking a number to some power, right? So when we write down powers, what do? Well, 2 to the power of 3, what does that mean? Well, this means 2 times 2 times 2, right? It's 2 times itself 3 times. Likewise, 2 squared, well, that would be 2 times 2. And 2 to the first power, well, that should be just 2, right? And so this would equal 8. This would equal 4, and well, 2 is 2. Okay, there we go. So that's a kind of straightforward way of how we take 2 to the power of something. What if we want to take it to some negative power, right? Like 2 to the negative 3. What does that actually mean? Well, it's a little bit strange. You can't multiply 2 by itself negative 3 times, right? Instead, what this indicates is 1 over 2 to the third power, right? And so this is going to be 1 over 8. Likewise, 2 to the negative 2 power, that's 1 over 2 squared. That would be 1/4. And 2 to the negative 1 power, well, that's just 1 over 2 to the first power, which is 1 over 2. And here is where the notation is going to come from, because notice that 1 over 2 is the reciprocal of 2. So the idea is taking any number and raising it to the negative 1 power, well, that is going to give us the reciprocal of that original number. So this gives us better notation for reciprocals. So here's our better reciprocal notation. We're going to say that any number raised to the negative 1 power, well, that is going to result in the reciprocal of it, right? And we can extend this for fractions, where any fraction a over b, taking the reciprocal of that is like you're flipping the fraction over, and you're going to get b over a. Perfect. Now, last time we found this using kind of an interesting story, right? So what we said was if we have some a to the negative 1, well, that's sort of like taking a over 1. We can make that into a fraction, right? So a over 1 is the same as a, and we know that this is going to be the reciprocal here is 1 over a, and you can kind of see that you're taking this fraction and you're flipping it over to get the reciprocal. So that was the story we told to justify this rule. But this story is not terribly rigorous. So let's see if we can actually demonstrate this a little bit better. I'm going to say let's start out with some a over b, and we're going to raise that to the negative 1 power. So we're going to take the reciprocal of that fraction. What is that going to be? Well, I just want to stick with this original rule. Okay, so I'm going to now write this as 1 over a over b. Okay, so you see what I'm doing. What this rule says is you take this number and put it in the denominator. So I'm going to take this number and put it in the denominator. So that's how I get this compound fraction. And now I want to try and sort of simplify that, right? How do I simplify this? Well, what I'm going to do is I'm going to simplify this by multiplying it by the number 1. So any fraction, any number multiplied by 1 will be the same exact value, because number 1 is the multiplicative identity. But instead of writing the number 1 as 1, I'm going to write it as b over b. So I'm going to multiply this by b over b, which is 1. What do I get now? Well, if I do this, I'm going to get b in the numerator, and in the denominator I'll have a over b times b, right? So I have a 1 times b in the numerator and a over b times b in the denominator. And notice what happens here is these b's are going to cancel out. And so now what I'm finally left with is just b over a. Just like that. Notice what happened. We started with a over b. We're taking the reciprocal of it. It gets flipped and we get b over a. So this should demonstrate why this rule actually works. All right, let's take a look at another thing we can do with reciprocals. Now I want to see what happens if you take the reciprocal of a reciprocal. Okay, so here's the idea. Let's say I have some number 4. I'm going to take the reciprocal of that, and then I'm going to take the reciprocal again. Okay, what is this going to be? Well, let's do the first one. Okay, so what's the reciprocal of 4? Well, that's going to be 1 over 4. And then if I take the reciprocal of that again, well, I'm just going to take that fraction and flip it over again. So that's going to be 4 over 1, which is just 4, right? So I get the original number back out again, right? That's what I'm going to get here, taking the reciprocal of a reciprocal. Let's try it with a fraction, okay? So let's say I have 2/3. I'm going to take the reciprocal of that, and then I'm going to take the reciprocal of that, okay? So do that twice. What am I going to get? Well, here the first reciprocal, well, that's going to be taking 2/3 and flipping it, so I'll get 3/2. And then I'm going to do that again. I'm going to flip it again. So taking that and flipping it again, I get 2/3. So just as expected, I get my original number back out again. Basically, you're taking a number and you're flipping it twice, so you get back the original number. Here's sort of the general rule. We can say that any number, and you take the reciprocal twice, you're going to get that same original number back out again. Okay, let's take a look at one more thing here with reciprocals. We're going to see how we can use reciprocals to get a fraction out of the denominator of another fraction. This is something that we kind of just did, right? When we were demonstrating this rule for reciprocals of a fraction, we had this intermediary step here. We had a sort of a fraction in the denominator of another fraction. And so that's what I want to focus on right now, this sort of intermediary step. So let's look at an example. What if I have some fraction here, 1 over 2 over 3, right? And I want to get this 2/3 out of the denominator of the bigger fraction. How can I do this? Well, what we did before was we would multiply by some number 1, right? And we represented that 1 as a fraction. In this case, we could do 3 over 3. So if we multiply this by 3 over 3, what are we going to get? Well, we'll get 3 in the numerator. Then we'll have 2/3 multiplied by 3. And these 3's cancel out, right? And so now what we get is 3 over 2. So we can get this 2/3 out of the denominator by sort of getting its reciprocal, okay? So we can take the denominator out as its reciprocal. So another way to think about this is if we had sort of rewriting this as 1 divided by 2/3. We also saw we could understand division as multiplication of a reciprocal. So this would be the same as 1 times 3/2, and that's just going to be 3/2. So once again, these two numbers are going to agree. So you can take any fraction out of a denominator by getting its reciprocal. That's the important idea here. Let's see if we can practice this with an example. Did you happen to get the number 8? Hopefully you did, because that's the answer we're looking for. We're going to find this answer a few different ways. So the first way is we're going to use our new rule, okay? So we're going to say that this is the same as, 2 times the reciprocal of whatever's in the denominator. And so the reciprocal here is 4 over 1. And so we can see this is going to equal 8, okay? So that's the first way we can do this. The second way we can do this is to think of this as 2 divided by 1/4, right? That's what this fraction represents. And this is the same as then 2 times the reciprocal, which would be 4 over 1. And here we get our 8 once again. Finally, we can look at this one other way. And that would be to think of this as just a compound fraction here, and we're going to multiply the top and bottom by the same number, right? We're going to multiply this fraction by 1, and in this case, we'll do this by multiplying by 4 over 4, okay? Now, if we do that, what do we get? Well, we're going to get 2 times 4 in the numerator, and then 1/4 times 4 in the denominator. Well, this is going to cancel out, and so we're just left with 2 times 4, and that's going to be 8, okay? So 3 different ways of showing how to sort of simplify this compound fraction by getting that fraction out of the denominator. Okay, so hopefully this was a good little deep dive into reciprocals and how we can use them.